Assalamualaikum and hello everyone. We are from Group 12 and today we are going to present BITI 3313 Image Processing and Pattern Recognition group project with a title of Brain Tumor Detection and Segmentation. I'm going to show us our group members. So the first one is Kishenthiran, anak lelaki Sagadevan, and next is myself, Muhammad Izzul bin Roslan, and then we have Muhammad Haziq Danish bin Muhammad Rozi. Introduction to brain tumor detection. Brain tumors are abnormal growth of cells within the brain that can be life-threatening. So, early and accurate detection of brain tumor is critical for effective treatment and improved patient outcomes. So, medical imaging, particularly MRI and CT scans, are essential tools in diagnosing brain tumors. Hence, our problem background is the challenge identifying and accurately segmenting brain tumors in medical image is a complex task due to variability in tumor appearance, size, shape, and location. Hence, there is a crucial need for automated image processing technique that can repeat process image, detect tumors, and segment them with high accuracy, thereby aiding radiologists and diagnosis and treatment planning. So why is image processing is relevant? Image processing techniques enhance the quality of medical image and make significant features more visible. And also, pattern recognition algorithms can automatically detect and classify regions of interest such as tumors in medical image. So our objective is to develop an automated algorithm for the detection and segmentation of brain tumors in medical image. So the specific goal is first we want to pre-processing, implement an anisotropic diffusion filtering to enhance image quality by reducing noise while preserving important features like ages. Next, segmentation, apply thresholding and morphological operation to accurately segment the tumor from the rest of the brain tissue. And next, we have a feature extraction to extract and quantify important features of the tumor such as area, eccentricity, solidity, and extent. And next, we are going to the methodology. So first, we start, and then the system will ask will ask us to input the image. So we load the input brain tumor image, MRI scan, and then it will pre-processing stage using anisotropic diffusion filtering to reduce noise while preserving age. And then we have a thresholding. Thresholding is to convert the filtered grayscale image to a binary image by applying a threshold and distinguish the tumor from the rest of the image based on cell intensity. And then we have morphological operation. This operation will label connected components in the binary image, and then calculate region properties such as solidity and area, and next identify the tumor based on the highest density and significant area. And then we have feature extraction where we extract and quantify tumor features such as area, eccentricity, solidity, and extent. And then it will calculate the tumor area in centimeter using the spatial resolution in a centimeter square. And then we have a bounding box. In a bounding box, it will draw a bounding box around the detected tumor to highlight its location. And then we have a tumor outline where it generate the tumor outline of the tumor using image filling, aeration, and subtraction technique. So lastly, we have a tumor highlighted in red. So we'll insert the tumor outline into the filtered image in red color to emphasize detection.
Okay, next for the input image sample, there are two types of image that we use. The first one is tumor image and the second one is non-tumor image. For non-tumor image, we use the sample image of brain with the tumor, while the non-tumor image is the brain without the tumor. Right, next for the output of the project, first we input the sample image into the system, and the function or system will filter the image to enhance if there any tumor in the brain, it will detect. If there no tumor in the brain, the system will conclude that there is no tumor in the brain. Right, next for output for tumor image. First, like the next tumor image, we input the sample image into the system. Next, the system will filter the image, which the function is to enhance the image if there is the tumor in the image, the system will put the bounding box outside of the tumor. Then it will separate the tumor in the brain. Then the system will irradiate and select the outline of the tumor only. Then finally the function will detect the tumor in the brain.
Hey sir, so this is the MATLAB code for our project entitled Brain Tumor Detection and Segmentation. So this code mainly run by me, Kishenthiran, and Izzul and Haziq. So now I'm going to explain the code by each segment. So the first segment is the image acquisition. Actually, this segment allows the user to select and unload an image from the file system. So the UGIT files opens a dialog box for the selecting an image file, while the strcat constructs a full file path by concatenating the path and file name. And figure I am sure title display the selected image with a title. So the next segment is the image enhancements. Image enhancement improves the visual appearance of the image or highlights the certain features using anisotropic diffusion. So the anisotropic function applies the anisotropic diffusion to reduce noise while preserving the edges, and the U in 8 actually converts the enhanced image to 8-bit format, and the RGB to gray is actually converts the image to grayscale if it is color. So this is the enhanced image will be displayed. So the next segment is the segmentation thresholding. So the segmentation is a partition the image into meaningful regions, here separating the tumor from the background. So the image will be resized to ensure it is 256 times 256 pixels, and the mean, max and minimum are used to calculate the threshold value TH. The nested loop here creates a binary image sort where the pixel above the threshold value are equal to 1 or others will be equal to 0. So the next segment is a morphological operation. Actually, BW label is connected the components in the binary image, while the region props are actually calculates the properties of the label regions. Properties like solidity, area are used to identify the high density regions. Max area tumor label are the region that with the largest high density area. So the next segment is the object recognition. Actually, object recognition identifies and highlights the tumor region. So if the maximum area of the tumor exceeds 200 pixels, all the properties are calculated and displayed. So the first properties are tumor area, which will be calculated in square centimeters. The second one is the eccentricity. Actually, eccentricity is how much the shape of the tumor deviates from being a circular. The third one is a solidity. It measures the shape density. The last one is the accent. It is a ratio of tumor area to of the bounding box containing the tumor. So the next segment is the bounding box. So the bounding box actually draws a bounding box around the detected tumor. So bounding box properties of the tumors will be extracted, and the rectangle is drawn around the tumor on the filter image to highlight its position. So that will be from this coding segment. So the next coding segment is getting the tumor outline, image filling, eroding and subtracting. So it will be the creates an outline of the tumor using a morphological operations. So IM fill is a fills the holes in the binary tumor image, and erection operation is performed to create an eroded images, and the eroded image will be displayed. So the next segment will be the subtracting eroded image from the original black and white image. So the extracts the tumor outline by subtracting the eroded image from the original tumor image. So the outline of the tumor is obtained by the setting the eroded areas to 0 in the original tumor image, and the tumor outline will be displayed. So the next segment is inserting the outline in filter image in red color. So it's actually overlays the tumor outline on the filter image in red color. So the grayscale filter image will be replicated to form in 3-channel image, which are red and green and blue. The image will be tumor outline will be in red color, will be in display. So the next are the display all the figures. together. So actually the subplot displays multiple images in one figure, showing the input image, filter image, bounding boss, tumor alone, tumor outline, and detected tumor for easy comparison. So the last segment is the anisotropic diffusion function. Actually, in this part, anisotropic converts the input image to double precision and initialize the partial derivative filters for the north, south, east, and west direction. It also computes the gradients and applies a diffusion function based on the chosen option. It also iteratively updates the image to reduce noise while preserving the edges. So these are the explain of this coding of the brain tumor detection and segmentation. Thank you. So now I'm going to demo the code of our project. So when I click the run button, it will directly goes to the document file document part. So before that I want to let you know that I have been separated the tumor image and non-tumor image into two different folder. So first of all I want to show the tumor image first. So I have been taken a 10 10 tumor image from the dataset I have been searched in the Google. So first of all I want to show the tumor image for number 3. So as we can see, we can clearly see that there are tumor in the original picture. So it will actually change to the filter image, and the bounding ops will be appear around the tumor, and the tumor alone will be shown, and a tumor outline will be shown, and finally the detected tumor will be in a red color. So before that, I have been explained the tumor area into a 22.49 centimeter square, and the accessory 0.6737 for that image, and the solidity is 0.97107, and the accent are 0.74372. So these are the output for the tumor image number 3. The next and the last part is the demo of the non-tumor image. So I choose the non-tumor image folder and choose one of the image that I've been taken from the data set. So I take the number 8. So as we clearly see the input image that I have taken, as there are no tumor. So the filter image will be formed and the status of the no tumor will be appear. So these are the output of the non-tumor image. Thank you.
Okay, next for the improvement and the feature works of the project. The first improvement is advanced algorithm, which utilizing advanced neural network architecture. For example, unit engines for more accurate and efficient segmentation. And next, applying pre-trained models on a large dataset to new dataset to improve performance with limited data. The second improvement is automated and real-time system, which is developing full automated system that can process and analyze brain image without human intervention. For the future works, the first one is personalized machine, which creating models that can be personalized to individual patients, taking into account their unique anatomical and pathological characteristics. The second one is integration with clinical workflows, which is collaborating with radiologists and neurosurgeons to integrate AI tools into clinical workflows seamlessly. Okay. Conclusion for this project is the project on brain tumor detection and segmentation using image processing and AI techniques has demonstrated significant potential to improve the accuracy and efficiency to diagnosing and treating brain tumor through the application of advanced deep learning models, multi-model imaging, and automated systems. We have achieved substantial improvement in both detection and segmentation performance. However, there remain several areas for future work that can further enhance these outcomes. Key areas for improvement include refining model accuracy through enhanced architectures and data augmentation, developing real-time and automated processing system, and integration this tool into clinical workflow with user-friendly interface. That's all from our group. Thank you for your attention.